Hello, everyone. Welcome to Tynker's webinar on using game design and computer programming to support math and writing standards. We'll just wait a couple more minutes as people arrive. I just wanted to mention that at any point during this webinar, if you want to message us, you could do that from our Google Plus page, or you can tweet. Our Twitter handle is @GoTynker. Please feel free to send us any questions you might have. We'd be happy to answer them during the webinar. And of course, after the webinar is over, we will have a link to the broadcast that you'll be able to access from this page as well. And we'll also put it out on Twitter. Great. Well, I think we're about ready to get started. I'll introduce myself. My name is Jennifer Appy, and I'm with Tynker. And one of the favorite parts of my job is going out to talk to teachers and students who are using Tynker and coming back to share the stories with you. So in today's presentation, I'll be sharing examples of projects that teachers and students have done that support math and writing standards. So we'll first go over what is Tynker, why schools choose Tynker, and then I'll show you some examples of these projects that support math and writing standards. First of all, let me just, for those who are not as familiar with Tynker, talk about what Tynker is. It's known as the easiest way to teach programming. It's a visual coding language that allows students to quickly put together blocks to create amazing projects, like this animation of the solar system. It's known as the easiest way to teach programming in schools because Tynker doesn't require you to know anything about programming to teach. Valerie Sabag at Fairmeadow Elementary says, "I didn't have to know everything up front. Kids learned independently and I learned along with them." And the best news is that teachers for free. One of the reasons why Tynker makes it easy is because syntax-based programming is hard for kids. Visual coding is much easier when they snap those blocks together and they represent things that they're thinking and that they want to do, as opposed to a syntax-based coding language that's a little bit more cryptic. And it's important that we make it easy for kids to learn because programming is a language of the future. If you look at the ways that technology has affected our world and changed it, it's mind-boggling. The top 10 high-demand jobs in 2010 didn't even exist 10 years ago. So one of our jobs is to prepare kids for those jobs that don't exist yet. And one of those skills that they'll need to know is programming, the language of technology. Troy Anderson, who is an instructional technology manager at the Elk River School District in Minnesota, recently had Tynker brought in for the entire school district, and his rationale was that in our increasingly technological world, coding is a language kids will need to know in the future. One of the reasons why Tynker is great for building those 21st century skills and Common Core together is that kids are engaged. They want to make their projects work. They want to do more things with code. And so what it creates is an environment for collaborative problem solving that also encourages students to read for meaning or inspires critical thinking while students are together storytelling projects, or are you supporting those common, also building those critical 21st century skills as well. Kathy Bottaro in Iowa says that Tynker's engaging platform helps our students learn those problem-solving skills in a way that supports academic growth in core areas such as reading, math, and writing. And finally, I will mention that teachers have found ways to integrate Tynker into many aspects of classroom curriculum. There's so many tie-ins that can be made. And that's what we'll be talking about today. We'll be talking about how coding can be integrated into the curriculum to support math and writing. Finally, why integrate coding into the curriculum? Why not use other tools? There are plenty of other ways that we've taught curriculum in the past, but the difference is that coding engages students in a very compelling way. As you can see, this picture of the students playing a game that they've built. And as I'll show you, it integrates with all curriculum areas. And what educators are telling us is that it provides an efficient and motivating project-based learning approach to giving kids an opportunity to develop those valuable problem-solving skills. So let's get into some of those examples. So when you look at the Common Core standards, the K-5 mathematical practices are well represented when kids are coding with Tynker. Kids are making sense of problems and persevering in solving them. They're reasoning abstractly. They're making mathematical models. They're attending to precision. If just one little thing is off, they need to go back and fix it and make it right. So it's developing that patience with trying to make things work and get things right. And it's also giving them the opportunity to look for and express regularity and repeated reasoning. So lots of ways that the mathematical practices are involved in Tynker projects. Jessica Falk, a first grade teacher in Iowa, says supporting mathematical practices in K-5 is fun in Tynker, and it's easy to do it that way as compared to our existing curriculum and textbooks. So we're giving teachers the opportunity to do what they need to do in a really fun way that kids enjoy. So here are a couple of examples to start with. These are math calculators that have been built by students, and I'm actually going to click in on this one here. Let's see. So that you can see how the project works. So in this project, I'm going to play it for you first, and then we'll take a look at the code. So the character says, hello, how much do you want to save? Enter a number of dollars. So I'll type in 100. And now she asks, how much allowance do you get each week? Enter a number of dollars. So let's say I get paid $5 a week. You will need about 20 weeks to get to your goal. So this is a simple project built by a third grader that took the division problem and put it into an engaging format. So you can see here that on start, all the mathematical counters are set to 0. The character says hello, then asks, how much do you want to save? And I typed in my answer. And then the character asks, how much allowance do you get each week? And I typed in my answer. And then those two answers that I gave were put into this mathematical formula. And then the character displayed the final answer on the screen. So this was a very simple way that a child took a mathematical equation and put it into an engaging format. Same thing was done with the temperature calculator, which is the other example that I have on the screen. And you have links to both of these projects, so you'll be able to click in on them the same way that I did and save them to your accounts. And you can assign these projects to your students as lessons. You can even turn them into tutorials. In our last webinar, we talked about how to easily create tutorials with Tynker. You would just go to Tools, Create Tutorial, and you'd be able to add notes and tell students what you want them to do. In fact, you could remove the code that's here, add the code in as instructions, and have them actually build this project from scratch. So very easy to turn these projects into lessons. One other thing that I should point out, this is a little bit off topic, but we did launch some new features of Tynker recently. One is this Canvas mode, and I'll just point it out to you in case your students find it, then you know what it is. The Canvas mode allows students to easily build levels of games. We will be putting out tutorials for this over the next few weeks, but this will allow them to very quickly be able to create compelling games and be able to add levels and other things that is going to really motivate them to do more with coding. And for those who haven't seen this yet, this code view block is our way of showing students the JavaScript that's behind the visual code blocks that they use. It's our way of transitioning them to mainstream programming when they're ready. All right, so I'm going to go back to my examples. Jesse Thorstad in Minnesota mentions also that Tynker provides kids with concrete examples of math. So as they're coding, they can see the actual impact of manipulating the numbers. So he's saying that his students experience a heartwarming aha when they see how adjusting a decimal affects objects on the screen tenfold. So in the project that we just saw, if I increase the wait time to 100 seconds from 10 seconds, kids would see the difference. That's a simple example. Walking 10 steps or 0.10 steps on the screen would be another example of how kids can see the magnitude of numbers very quickly when they're working on coding projects. Now, when you create games, they require some real math skills, and here's some examples of the skills that kids need to implement. When they're putting together a good game, there's a good guy, there's a bad guy. They need to perhaps position them in a certain place on the screen. They need to position them at a certain angle on the screen, or maybe the angle is set by moving a cursor key or a letter key. They need to calculate points, they need to set their score counters, and maybe time the interactions between characters in their games. So there's quite a bit of math that kids need to use. And here's an example of the code in this tutorial that was created for Hour of Code. We're providing the link to you here. Just click on this, save it to your account, and you'd be able to assign this project as a lesson. But this is a half-made game that will allow kids to get right into the thick of it. They can see how the existing gameplay works. They can add to it, and the instructions show them how to finish the game, and it's requiring them to think through the math skills that they need to make the gameplay awesome. All right, here's another example of how we incorporate math into coding projects. Math art is a wonderful way to get students to appreciate the artistic beauty of math. In this math art project, you can actually see with the code on the left that there are two nested repeat loops, one that creates a circle of a small diameter and one that creates a circle of a larger diameter, and that's what is creating the beautiful pattern that you see on the screen. I have a link here to the code, so again, you can save this project to your account and you can have your students manipulate or create this project as well. And this is the math content standard that a lot of our math art relates to, drawing and identifying lines and angles and classifying shapes by properties of their lines and angles. So there are lots of ways that our projects will map back to the standards that you're trying to meet in the classroom. We also have a pattern maker activity that we launched for Hour of Code. It encourages kids to explore geometry. And again, click on the link and you can save this to your account. Now, for more advanced students, you can use physics-based games to explore math as well. This was another game that we launched for Hour of Code. It was called our two-player cannon game. Again, it's a half-built game that actually has the code for one of the cannons created, but not for the other. But if you went into this project and took out all of the characters and just played with the cannon, you could have students experiment with these angles based on the trajectory of the ball that comes out of the cannon. So it's a great way to kind of bring to life some of the principles that you're trying to introduce in the classroom about angles, arcs, and distance. Finally, we threw in a number of projects that students have done that show an example of reteaching. They're taking math principles, maybe they're teaching younger students, but they're taking what they know and they're incorporating it into a coded Tynker project. Valerie from Fairmeadow also mentioned that when kids reteach, their understanding of the concepts increase, and each child gets a chance to shine, to be a leader, and to share what they know. And the kids who created these projects were very proud of what they accomplished. On our website, we have examples of how our lesson plans map to Common Core. This map is for math standards in particular, but we also have a mapping for ELA as well. So let's go ahead and move into ELA and writing standards. Here are the standards for grade 3, and I've also put up the standards for grade 5. So you can see they're very similar. They're just expanded upon a bit more for 5th grade, but all of the added detail that a student would need to put into their writing project can be done with a Tynker project. So here's an example of a project that would meet that standard of informative and explanatory text. So in this project, this was actually a final project for science, the student had to write different facts about the parts of the Earth and had to illustrate it. In this coding project, this is how it was included. So the different facts were included as say blocks. And when I'm looking at the blocks here. So broadcast crust, wait 3.3 seconds, and then say the next layer of the mantle is the largest. So what they're doing is animating in the labels here, crust, mantle, and outer core. And as the labels animate in, the facts are displaying on the screen. So again, it's just an interactive, enjoyable way to present a final project that might have just been on paper. Now it can be an interactive tutorial coded by a child. Here's another example of a cross-curricular tie-in with science where the factual writing is included in speech bubbles on the screen. And it just makes a more engaging way to present what the student knows about, in this case, about the water cycle. And Sarah in Austin says that with Tynker, her students can not only learn those valuable programming and critical thinking skills, but they can reinforce their knowledge in many academic areas. So in this case, we're showing an example of science, but there are many other academic areas that these coding projects can support as well, and reinforce those informative and explanatory text and writing skills that are part of the core standards. Now here's an example of an interactive project. This was a student who created a family tree. And when you click on the characters in her family tree, the characters will introduce themselves and their occupations. And this is the code that she put in for each of the actors. So when actor clicked, in this case, Maria says, "Hola, me llamo Maria." And she explains that she is this person's grandmother and a doctor. So you can see it's just taking a writing project and giving a child a more engaging way to present the information. And in some cases, teachers have said that because this is an alternative mode of artistic expression and creative and communication expression, that it's actually engaging kids in ways that they have not been engaged before. It's giving them another outlet for communication. So we've talked about informative and explanatory writing. Now let's talk about narrative writing. And the standards for grade 5 are very similar to grade 3. So here's some projects that were created by students. One is a fictional narrative, so telling stories. One is a historical fiction, and one is a multi-level game. Now, you might think, okay, what does this have to do with what we teach them in terms of storytelling? But any approach that you take to teaching writing, whether it's with writing webs or with other planning documents, any way that you teach writing, you could have them deliver their final output in this way. And teachers are finding this to be a really engaging way to get kids to create stories and write. So Kathy in Iowa says her third graders created stories with dialogue and lively characters in Tynker. They were so caught up in creating and narrating their stories, they didn't even realize they were coding, writing, and crafting a compelling storyline at the same time. So the principles are the same. When you're creating a great story, whether it's interactive or whether it's on paper, you need to have great characters, you need to have a really strong plot line, a story arc. You need to set up your setting in a way that's compelling to the audience. And you need to deliver it in a way that the audience will understand. So sequencing. All of those things, all of those skills can be practiced when you're putting together an interactive story. And this is a means that kids understand. They engage in this type of media every day. So encouraging them to tell stories in this way is a very natural thing for them. With multi-level games, the principle is the same. A lot of, and kids know this, a lot of strong games have very strong storylines, great characters, great dialogue. So kids can plan the storylines for their multi-level games in the same way. So many opportunities for creative storytelling using Tynker and coding projects. We also launched a project for our Hour of Code called the Comic Creator, and there's a link to this project as well that you can save in your account. But it's an easy way for kids to think about sequencing, to think about dialogue, to think about how to create comedy, how to create really dynamic and interesting characters, and how to tell a story. This is an example of a grammar quiz, and actually we created this as an example for teachers to see how this question-answer format could be easily implemented as a coding project. So you can see in the code that there is a prompt, and the prompt says, can you help correct these sentences? Type in the corrected sentence. And then after the user types their answer into this box, there is a comparison with the right answer. So we're teaching students simple conditionals here. If what the user typed in is the correct answer, meaning what has been hard-coded in as the right answer with the right grammar, then what will be broadcast is a star as a reward. And here I think there's a say block that says correct, you get a star. Otherwise, if it's not the correct answer, there will be an error condition saying no, try again. So this is a very simple project to show question and answer, but in this particular case, we used this as a grammar quiz. It's a great opportunity for reteaching. As I showed with the math projects earlier, if you have students create a coding project around vocabulary or grammar or something else that you want to reteach in the classroom, it's just an engaging way for them to practice and promotes deeper learning. Finally, I'll leave you with this thought. This wasn't necessarily tied to one of the ELA standards, but a more general thinking and logical organization standard. Lucinda Ray, who is an educator and a writer, states that coding helps develop the organizational skills required for good writing. She encourages her students to plan their projects by breaking down their topics, selecting evidence, grouping together the points that are related to each other and sequencing them in a compelling way. And she likens those skills to the same planning skills you'd need when creating a video game. So she sees coding as an opportunity to engage her students in developing those logical organization and thinking skills that they need for good writing, that maybe they may not enjoy doing it through the writing process, but if they're doing it through coding, they can apply it to writing and it just makes their writing stronger. And finally, here's our mapping of lessons to the Common Core standards for English language arts. So one point that I mentioned earlier, and this came from Sarah in Austin, is that not only does coding support math and writing standards, but it can be integrated in all areas of the curriculum. And these are examples of things that her students have done in many different areas. And I'm actually going to play this video for you now so you can get a sense from a child's point of view what these projects are like.
What I did was I made it so with choices of Babylonian and Greek. I click Babylonian, it's going to say beginner's luck. But if I click Greek, then it's going to say for better study more.
And then when after clipped, it looks like his guitar is just lying in here. But really, I'm just changing his costumes. It's like stop motion. So I did all these costumes to play in a row. I did go through costumes 5 times. So 1, 2, 3, 4, and then went back to getting one. Then has guitar playing here. I really enjoyed this if then else, because if the answer is 60 miles per hour, then say great job, ready for the next one. But if they did not get it right, then say I'm sorry, that's not correct. The correct answer is 60 miles per hour. Okay, yeah, you can hear your voice in the background. So I should go. I had all these scenes. I actually didn't code the scenes. I just coded them on Free to Call Up and said like change this, and I did a lot of looking into the different scenes, which was hard at points, but really fun. The moon is orbiting around the Earth. The Earth is spinning around on its axis, and the tides are being affected by the sun and the moon's angle. The moon, this was a pretty complicated code, so you make it start at the same place. And then when you click the up arrow, I had to kind of play with this. He orbits around the Earth in almost a perfect circle, best as I could get it.
Great. We noticed that there was a question about turning on the video camera. We'll do that at the end. Unfortunately, we hadn't set up the webinar to broadcast live video, but happy to do that at the end and would definitely welcome any questions that you have. All right, let me go through some lesson planning support because we showed you a lot of projects and a lot of different ideas. Let me show you a couple of things that we have to help make the lesson planning easy. So the first tool that I mentioned was the tutorial creator, allowing you to turn projects into lessons. And we showed you a lot of projects. You could turn any of those projects into lessons. If they're not already, if the tutorials aren't already there, you could definitely turn them into tutorials yourself. You can also do this with any projects you've created or that your students have created. Your students can even create tutorials for each other. So that could be part of your assignment to them, could be to create a tutorial based on a project that they've done. There's a link here to our blog post that explains how to use the tutorial creator, but it's very easy to do. As I showed you earlier when we were in the Tynker project, you just click Create Tutorial, and then you start to add text, and you can upload images, and you can add links to web pages or videos. You can drag in code blocks, and you can make it a very engaging tutorial for students to follow. You can see here the code blocks have been dragged in to the note to show the students what to do. You can also access help from within the tutorial creator very easily if you need to know how to add any of these things to your tutorials. This is a sample tutorial, and actually in the project for the comic creator that you click on, you will actually see this tutorial, and you can change it. You can use it. You can add voiceover for it. You can do anything that you'd like to do to it. And this is actually here the link is again to the same tutorial. Now we also have ready-to-use guided lessons, and when teachers want to start to teach programming concepts in a scaffolded way, grade by grade, our ready-to-use lesson plans make it very easy for teachers and schools and districts to do this. And our lessons do go through a lot of the similar projects to what what I've shown here today that teachers are doing in the classroom. But the guided lesson plans make it very easy to teach. And you can find out all about our lesson plans on our website. One of the things I should mention about our ready-to-use lesson plans is that the guided independent learning approach that we take is what makes Tynker so easy to teach with. This is an example of a guided tutorial where a character will come out and will show the student how to use certain blocks or explain a concept. This is a coding puzzle, which we put in some of the lessons in order to give students practice with a particular concept once it's been introduced. And Dave Villafana, who's a CS technology teacher at Miller Middle School, actually told us once that the guided structure did all the teaching, so he didn't feel like it was a burdensome class, and that was one of the reasons why they implemented Tynker in their CS program at Miller Middle. He says the great lessons make it a class that basically runs itself with lots of student engagement. So thanks, Dave. So this is just a glimpse of what's in a Tynker lesson. I talked about the interactive videos. There are also hands-on tutorials that will step a student through and show them which blocks to add so that they have practice with certain concepts. There's a DIY project that helps them to put what they've learned into action, coding puzzles I mentioned earlier, and finally a quiz at the end. So all of our ready-to-use lesson plans are structured in this way. And these ready-to-use lesson plans provide a comprehensive approach to building programming skills from beginner to advanced. So we start them visually with visual code blocks, and the goal is to transition them to a mainstream language like JavaScript. And I showed you earlier the code view that helps to make that transition possible. When the Scarsdale School District adopted us, one of the things that their technology teacher, Paul, said was that Tynker's solution develops logic and programming skills at younger age and builds grade by grade, allowing us to properly prepare students with 21st century skills. So as kids are going through these lessons, they're building their problem solving and critical thinking skills, and also their programming skills as well. But as you saw in the earlier examples of projects, they're also tying this in with every curricular area, and it's supporting all of those important skills that kids need to learn and the teachers are teaching. And this is just a mapping of what our course sequence looks like. It makes it very easy to get started at any grade. So if you have students who haven't started programming and they're fifth graders, this would be their sequence. But if they're starting in third grade, this would be their sequence. So we have a way to get kids started and ramp them up from beginner to advanced. Finally, with a very successful hour of code and with the district adoptions that we've had in the past year, we are now in over 15,000 schools and enjoyed by over 20 million students. So we're grateful to all of the wonderful schools that have adopted Tynker, and we hope that your school makes the list as well. Before I open it up for questions, I'll just mention that our next webinar was originally scheduled for next week, but we've moved it out a couple of weeks because of a few conferences that we're going to be at. So we hope that you join us for our next topic, which is teaching digital literacy and fostering deeper learning, where we'll hear from teachers about the differences that the coding is making in the classroom and how it's really fostering some wonderful benefits with students. And when you get the deck, you'll be able to click through to our RSVP form. All right, so I promised I would turn the video camera on. Let's see if I can figure out how to do that. Okay. So I'll open it up for questions. Okay, there's a question about whether in the future you can submit student projects to us for the Explore section. Absolutely. We are always looking for great examples of student projects. In fact, that's how we got a lot of the projects that I showed you here today. We talked in our last webinar about the possibility of a contest, but let's not wait. Let's get all of the projects that you want to share with us in as soon as possible. We would love to be able to share those with other students and teachers and inspire them to do more with programming. So please, please feel free to send them in. Great, so there's a question about answer keys. For Hour of Code, all of the answer keys for those projects are posted on the teacher guide page. So if you're on the teacher guide page and you're logged in, your teacher, just click on the answer keys link for the answers. Now, if you're in the product, we do have answer keys in our user guide. And if there's a specific lesson that you're looking for an answer key for that you can't find, can you please email us, or you can contact me at jappy@tynker.com, and I'll make sure that we can find the right location for the answer key that you're looking for. But we do have answer keys for the coding puzzles. Are there any other questions? All right. While we're waiting for more questions to come in, I'll just share a few final slides with you. One of the things that I should mention is we talked about our comprehensive curriculum, but we also want to make educators successful when they implement this curriculum. So one of the things that we've developed is a dashboard that allows you to easily monitor progress that your class is making against the programming concepts that we teach. We also make it very easy for you to add classrooms and students and to manage those students and share their projects. So we're designed to make you successful. And one of the things that Jenny at the CETA STEM Magnet program mentioned is that easy classroom management is a huge differentiator. Adding and tracking hundreds of students is seamless. So she appreciates the tools that we've created. So thank you very much, Jenny, for that comment. I also mentioned the transition to mainstream programming. And just to summarize, the difference that Tynker makes, the engaging and fun approach that we take is really what makes the difference with Tynker. Kids are engaged, they want to create, and that makes everything easier. We also make a point of meeting your goals as an educator. We want to make sure that we're helping you to achieve those learning outcomes that you're striving to meet. So allowing you to flexibly integrate Tynker into the classroom, meeting Common Core standards, CSTA standards, and providing you with opportunities to enhance STEM and STEAM learning. All of those things are very important to us. And finally, Tynker is designed to make you successful. We want you to be able to show the results from what you're doing and be able to do it in a way that saves you time and is easy. So thank you very much for attending our webinar today. I don't think there are any more questions, but if you do come up with anything in the future. Oh, wait, there is one more question. When is messaging coming back to Tynker? Messaging. I'm not sure if you're referring to messaging blocks or to something else. But if you could, we'll take this offline. I definitely want to answer your question, but I think I need a little bit more details on what you're needing to know. So I'll thank everybody for attending our webinar today. Really appreciate your interest in Tynker. Tell your friends, invite them to our next webinar where we talk about teaching digital literacy and fostering deeper learning. Thanks so much.